Have you ever wondered how scientists test their ideas? In this video, you will discover the key steps and term behind hypothesis testing, the backbone of scientific research. Stick around because understanding this process can make analyzing any data easier and more enjoyable. Hi and welcome back to our channel. Today we are breaking down the basic of hypothesis testing, what it is, why it is matter, and how you can use it to interpret statistical result. By the end, you will be able to define the central term and spot hypothesis testing in action. First, we will see some key terminology of hypothesis testing. First up is the null hypothesis, which assume there is no effect or difference. Next, it is a alternative hypothesis, proposing there is an effect. Next one is a significance level, usually set as 0.05, which is a 5%. Tell us what's considered statistically significant. The p-values help us decide whether to reject the null hypothesis. Don't forget about type 1 and type 2 error. These shows the risk of drawing the wrong conclusion. Throughout the hypothesis testing, you will use a term like test statistics, critical values, degree of freedom. Each play a role in making sense of results and deciding what's meaningful. Let's explore a quick example together to see concept feel more real. Here are the essential steps in hypothesis testing. First step is a state the hypothesis. You start by forming the null hypothesis, usually called H naught. This asserts there is no effect or no difference. Then you state the alternative hypothesis, what we actually hope to prove. Step 2, choose the significance level. This is the risk called alpha that we are willing to take it wrongly rejected the null hypothesis. Common values are 0.05% with 5, which is nothing but a 5%, 0.01, which is nothing but a 1%, or 0.1%, which is nothing but 10%. Step 3, select the appropriate text. Depending on the data and research question, you choose a statistical test. This could be a test, t-test, chi-square, or ANOVA. Now step 4, which is a collecting data. Gather the representative sample to ensure the evidence you collect is reliable. Fifth step is calculate the test statistics. Use the sample data and the choose test to computer test statistics. This measure how much the observed data diverge from the null hypothesis. Determine the p-values, which is nothing but a step 6. Calculate the p-value, which tell us the probability of getting the observed result, or once even more extreme if the null hypothesis were actually true. In step 7, we take a decision, compare the p-value to your significance values. If the p-value is less than or equal to alpha, you reject the null hypothesis and support the alternative. If it's greater than, stick with the null hypothesis. Step 8, which is nothing but a report result. Transparent reporting means sharing your hypothesis, the test used, the test statistics, the p-values, and your conclusion. Let's make this real with a simple example. Imagine you want to test if a coin is fair. So in step 1, first we'll calculate the state of hypothesis, which is nothing but null hypothesis. The coin chances of landing head is 50%. Alternative hypothesis, the chance is not 50%. Now let's choose a significance value, which is the 0.05%, 0.05, which is nothing but 5%. Then we'll calculate a step 3 and step 4, which is nothing but you flip a coin 100 times to gathering the data. Okay, so we flip the coin 100 times and get 40 heads, suppose. So we calculate whether getting 40 heads instead of expected 50 is a statistically significant. For this, you might use a binomial or z-test to calculate statistic values. Now let's calculate a p-value. If it is less than 0.05, that's evidence against the fairness. Now step 7, we suppose the p-values is less than 0.05, you reject the null hypothesis and conclude the coin is probably not fair. That's it. This is a process can be used in countless real world situations to guide a decision and support a claim with the data. Thanks for watching and stay curious.